Hello my viewers once again and welcome to TVEC Practical Channel with Mr. Mark Mariko. Remember the channel being a practical channel, I do give a contents on how a typical trainee can conduct practical sessions successfully for better performance during internal and external assessment. And number two, to units that may seem a bit difficult for them to understand, like these measurements, I use an archiCAD program to demonstrate step by step how to do measurements now. And then the third method that I use is the real project that I do cover myself, performing them in the field and then post them here so that trainees can get acquainted on how to perform these jobs in the field, because eventually after completing their studies, they will proceed to the field to do these jobs. Now in this episode, I have a unit here called Measurements, Estimation and Costing Principles. It has three parts. The first part, that is the measurements. We did in our first part, that is the takeoff, and this is the link. So we have the estimation part and then we have the costing part. And for you to do the costing now, first of all, you have to do the squaring process now. So this squaring process is going to allow you to square areas, to take linear measurements, to cube the volumes, and whatever you have gotten from this process, you are going to use now the rates to do now the estimation and eventually arrive at the costing. So in building and civil departments, I have these trainees with their various modules. So stay tuned, please subscribe, share and comment. So our then will be squaring for substructure works up to including DPC, all provisional. Remember, I'm referring to drawing number 01 that we had in our first part when we were taking off. So the first item when we were taking off was excavation of vegetable soil, and the area was 12.40 by 8.40. If I multiply these two figures, I get 104.16. So that is the figure that I'm writing here inside the squaring column. Remember, in this column, we do write items that cannot be enumerated, items that can be enumerated, linear measurements, square measurements, and finally cubic measurements here. So remember to have this double line to close these figures, as well as paging your dimension paper for easy follow-up. And I'm going to combine item number 2 with item number 1, that is the disposal of excavated materials. Remember, I have a depth of 150 millimeters, which is less than 300 millimeters, which is supposed to be booked here. So this one being less than that, I'm writing it in the description column. So if I multiply 0.15 by 104.16, I'm getting 15.62, which is approximately 16 cubic meter. So if I have to prepare bills of quantity, I'm going to use 16 cubic meter as the volume of the soil which is disposed on site. So watch the following video clip, the demonstration of how to come up with these values. Remember, the channel is about bringing this unit into the practical perspective so that you understand it better. And so by demonstration, assume this is the site. This green part you are seeing is the actual grass on the ground. So I have to dig this now to remove this topsoil so that I can start any construction work on this. So by doing that, this is what is going to happen. So the length will be from this corner to this edge will be 12.40 by a width of 8.40. That is from this corner to this corner. So I first of all book that, and then I square this length by this width, which if you refer to that was giving us 104.16. And the same area, now I'm now writing it in the squaring column. But if I want to know the volume of the soil that I'm going to excavate, I go further and multiply that by 150. That is from this upper edge of topsoil, now from this upper edge to this downer edge. So this is 150 millimeters I'm talking about. And since it is less than 300 millimeters, I do write it in the description column. So I multiply the area that I've gotten times this depth to know the volume of the soil that I'm going to excavate. And further, I dispose that here. So if I do the disposal, I end up with these heaps. So this is a heap, this is a heap, this is a heap, this is a heap, all these are heaps. and they are 30 meters from this edge. So I dispose them on site, meaning I can reach them later to reuse them. And now to third heading, that is the trench excavation. Remember, we are moving on with these two titles, that is the substructure works, and it is a continuation, as well as the squaring process, as well as paging. We are in page 208. Explanation will be excavate foundation which are more or equal to 0.30 meters in width and equal or less to 1.5 meters maximum depth from reduced level. So from our first takeoff, whereby we have a plan which was having a mini-gut foundation of 39.20, and that foundation in our first part when we were taking off was having a width of 0.60 and a depth of 1.05. We're going to multiply all these values and then enter that value in this squaring column. So if you do that, we get this value, that is 24.70. And now let me combine this item number 4 with item number 3, that is the disposal of the excavated materials, which can be done on, meaning within the site, or off the site. And if it is on the site, let me assume the distance is 30 meters from the excavation point. So this volume that I've gotten here is what I'm now having here as the volume of the soil that is going to be disposed. So it is 24.70 cubic meter. So if I have to prepare bills of quantities, so I'm going to use this one, and it's going to give me a leeway on which method I can use to dispose this one now. So watch the following video clip demonstrating all this now. Now to demonstrate trench excavation, assume this is the actual site now. So you can see we have the ground level, we have the reduced level. So we are going to have a trench excavation starting from the reduced level here. So when doing that, you take the mini-gut when you are now booking, which is the 10.20 all the way around, just taken from the center line of this, by this width now from this edge now to this edge, that is 600 millimeters, turned into meters, that is 0.6, by from this upper edge to this lower edge, that is 1.05. So you square all of them, though they are cubic in nature, but the term used is squaring process. And now to demonstrate how to dispose this, remember you have a mini-gut here, which if you multiply by the width and the depth is giving you a volume of soil, which upon excavation must be disposed. So you can do it on site meaning within the site, whereby you can again reuse them to do backfilling, or off the site, meaning away from the site and you are not intending to use them. So I will demonstrate how to do the disposal, whereby from this edge to these hips, these are the hips, this distance here is average 30 meters from the site. So you can see these are the hips which have been excavated from this trench now. So this is the demonstration thereof. Now to the fifth item, that is the surface treatment. So explanation will be reading compacting bottoms of the trenches by manual ramming. So our trench, according to first part when we did the takeoff, was 41.60 and the width of the trench was 0.60. So if I multiply these two figures, I'm going to enter that value in this squaring column. So the area is 24.96. So that is the area. When I'm preparing now bills of quantity in terms of labor, I will be now billing this area to be compacted. The sixth item will be blinding now, and the explanation will be in situ concrete, and this is the class and this is the ratio, 50 millimeters thick poured against the earth. So in our first part when we were taking off, you had a mean gut of 39.20 by a width of 0.60. So if I multiply these two figures, I get 23.52. So this being the area, if I'm interested again to get the volume of the concrete to do that blinding, I turn these 50 millimeters into meters and then I multiply these two values, of which if I do, I'm getting 1.176 cubic meter, which is approximately 1.2 cubic meter. So when I'm now proceeding to do the bills of quantity, the volume of the concrete to do the blinding will be now this one. So watch the following video clip elaborating all this now, this first one and this one. And to demonstrate the bottom surface treatment, it is simply compaction of this bottom part. Let me give you a closer range. Closer look is this bottom part now. Let me give you a closer look. It is this part now. So when the workers are digging it, it might not be that straight at the bottom to receive the blinding. So it needs some minor adjustment and some compaction that can be done manually or by the machine. So when doing that ramming, you book it using this extreme edges now, this outer edge, this one now running on the ground level by this width now from this edge to this edge. So you book it as 41.60 as power case by this width of 0.60 and then you square. And now to demonstrate blinding, it is these pebbles like what we are seeing here representing that, and it is poured to receive foundation mass. So let me extract it and then place it on the hair so that I can explain every details of it. So this is the blinding I'm talking about. You can see it now better. And the girth, I'm taking it from the center line and it is 13.20 by a width of 0.6 meters from this edge to this edge. So it is what I write in the dimension column and then I square. But if I want to get a volume, I go further and multiply by this thickness now from this upper edge to this lower edge, that is 50 millimeters, to get the volume, which I now carry forward to the bills of quantities. Next is foundation mass, and the explanation will be in situ concrete. This is the class, this is the ratio, and it is 150 millimeters thick, poured on blinding. So remember, in our first takeoff, we had a mean girth of 39.20 and the width was 0.60. So we multiply these figures and the value that we have gotten, we are writing here in the squaring column. So by multiplying them, I'm getting this value, that is 23.52. So if I'm interested again to get the volume of that foundation mass, I multiply this one by this, and first of all I turn this one into meters, that is 0.15. If I multiply by this one now, that is 23.52, I get 3.528, which I can round off to 3.5 cubic meter. Next item will be foundation wall, and the explanation will be 200 millimeter stone wall in stretcher in cement mortar, ratio of 1:3. Remember, in our first part when we did the takeoff, we had a wall which was having mean girth of 39.20 and the wall height was 1.1. So if I have to square this one to have those values here, I simply multiply these two figures and I'm getting 43.12. So if I have to get the volume of that wall for the sake of deduction for the ram and fill and adding cutaway as well as billing, I turn this one into meters, that is 0.2 times this one, which is giving me 5.1744, or if I round off, it is 5.2 cubic meter. So watch the following video demonstrating foundation mass as well as the foundation walling. And so if I want to get the volume of this foundation mass, I will multiply the length, that is the mean girth all around, times the width times the depth. This is from this upper edge to this lower edge, and the volume that I'm going to get. I proceed now to the abstracting and eventually to the bills of quantities. So to demonstrate foundation walling, it is this wall. This is the foundation wall, and the mean girth is taken from the center line of this, and all around we are having a mean girth of 39.20. Let me give you a close range. The mean girth I'm talking about we are taking it at the center of this. So from this edge to this edge, we take it at the center of this. And the depth, that is 1.10 meters from this edge now down to this foundation mass. So when I'm now writing this one into the squaring column, I start with the length, that is the mean gap all around, and I follow with the depth, that is 1.10. So this 200 now across from this edge of the wall to this edge, it is less than 300. I simply write it in the description column. So if I want to get the volume, I multiply the length by the depth and finally by 0.2 meters to get the volume of this foundation wall. So it is that volume that I carried out to the Bills of Quantities. Item number 9 will be filling to excavation, and remember it is internal. So explanation will be return, fill and ram selected excavated material around foundation, that is 200 millimeters wide. Remember we had a mean gap for internal to be 37.60 and a depth of 0.85 from our previous takeoff. So if I have to square that, I multiply these two figures and I'm getting 31.96. So if I have to get the volume to be used in backfilling for the internal, I turn this 200 millimeters into meters, that is 0.2, and I multiply by this, and I'm getting 6.39 cubic meter. So this is the volume that is going to be used to do backfilling for internal. Item number 10 will be filling to excavation, that is external. Explanation will be return, fill and ram selected excavated material around foundation, that is 200 millimeters wide. Remember we had this mean gap for the external, that is 42.40 and the depth of 1.00 meters. So if I have to square that, I simply multiply these two figures, that is giving me 42.40. So if I have to go further to get the volume of that soil that is going to be used to fill external foundation, I turn this one into meters, that is 0.2, and then I multiply by this, giving me 8.48 cubic meter. So watch the following video elaborating more on this internal filling and this external filling. So to demonstrate that backfilling, remember there's a void, this void now. After a foundation slab, we have this foundation wall, and because there's a trench which was dug here, this is the reduced level. So this void needs to be filled just before doing the hard coring over this, and it is having a depth of 0.85 meters from this edge down to this foundation slab. So when I have to enter this one in the squaring column, first of all, I get the mean gap all around, and it is 37.60. And that 37.60, I drive it from the center line, that is between this edge and this wall. So there's a center line here, is where I get that mean gap. And when I'm now entering those values in the squaring column, I use that mean gap all around, that 37.60, by this depth now, and the depth is from this edge down to this foundation slab mass. And because this width now of this backfilling is 200 millimeters, I simply write it in the description column. But if I want to cube the whole thing now, I turn this 200 millimeters into meters, that is 0.2 meters, and then I multiply by the mean gap, that is 37.60, by this depth now, that is 0.85. So when I keep everything, it is that value that I now carry on to the Bills of Quantities. So suppose this is a real site, you have this foundation wall, and before having this wall, there must be a trench to be dug here and foundation laid. And for the safety of the workers, you have to do the backfilling to the external trench. So from this extreme end of the wall to this edge, here is 200. So the minigut here is what we take to quantify or to enter this dimension, the squaring column. So let me give you a close range of how that filling has been done. Let me give you close range. You can see this is the wall height. So the filling was done all the way from this lower edge up to this upper edge. And now if I'm interested to get the volume of this excavated material that is supposed to be used to do the backfilling, I'm going to get a minigut all around, and let multiply that minigut by the width, that is from this end up to this end, that is 0.2 meters, by this depth now, which according to our dimensioning was 1.00. So that one will give me the volume of the soil to be used in backfilling. So that volume I transfer to Bils of Quantities so that I can know which means to transport that soil back to this backfilling work. The 11th item is hardcore. Explanation will be compacted in layers of 200 millimeters thick. So these are the values. We had the length of 11.60 as the length for the internal dimension of that structure, by a width of 7.60 by a depth of 0.31. Remember, if the thickness of the hardcore is more than 300, now we can now book it here. So if I have to square this, the term squaring applies even to the cubic units. I'm getting this 27.33. So this is the volume of the hardcore that I'm going to use to do the hardcoring. And then I have to have this one for the sake of deduction and ram and fill, and then cutting away, as well as the preparation of bills of quantities. The next item, that is number 12, is maram blinding, that is being done on hardcore surfaces. So we had, according to our plan of 01 drawing, internal dimension is 11.60 by 7.60. So if I square this, I'm getting 88.16. So if I have to get further the volume of this maram blinding, I turn this 75 millimeters into meters. That is going to be 0.075. And if I multiply those values, I'm getting 6.612 as the volume of the maram that I should be using to do the blinding. So watch the following video demonstrating how to do hardcore as well as how to do blinding. So by demonstration, the whole of this surface has been covered by the hardcore. Remember, I'm using the interior corner from this to this interior corner to be 11.60 meters. Likewise, to the width, I'm using the interior dimension from this interior corner to this interior corner to be 7.60. So when I have to square this one, I multiply those two figures by the thickness, and the thickness of this hardcore is 310 from our previous takeoff, and that is from, let me give you close range, that thickness is from this upper edge to this lower edge. So when I'm now squaring this one, I treat it as a cubic dimension, whereby I multiply the length times width times thickness, and that is the volume of this hardcore that I'm now carrying to the Bills of Quantities. Now, all these are blending which has been done over the hardcore, and to square this one, you simply multiply the internal now dimension, that is 11.60 by 7.60. So you get an error of 88.16, but now it is 75 millimeters thick. Let me give you close range. It is 75 millimeters thick here. So if I'm interested to get the volume of that blinding, I multiply 0.075 by an error of 88.16, and the volume that I'm going to get is the volume of the blinding that I carry now to the Bills of Quantities. 13th element is anti-termite, and the explanation will be treatment to blended surfaces of hardcore measured separately. So when we are booking such, we book them as an item, and when we are entering them in the squaring column, we enter them as an item. And that is this one now. So next is the damp-proof membrane. Explanation will be 500 gauge polyethylene sheeting done as damp-proof membrane. Remember, the measurements of our drawing was 12.00 by 8.00, and it is done to the extremes. So if I have to get the area that is supposed to be covered by this damp-proof membrane, I simply multiply these figures. That is going to give me 96.00. 15th element will be a formwork, and the explanation will be sewn formwork to the edges of bed, and that formwork must be 100 millimeters high because it is going to receive the concrete that is going to be done on that structure. So we use the perimeter all around to have the length of this formwork. So if I have to square this, I'm going to treat this one as linear measurement, giving me 40.00 meters. So watch the following video demonstration on how to do anti-termite, DPM, as well as the formwork. So it is over this blending that we are going to apply that anti-termite. Remember, when even booking that, you book it as an item. You cannot enumerate it now. And even when you are now transferring that one to the squaring column, you simply enter that in the squaring column as an item again. So it is that an item again that you proceed now with to the Bills of Quantities. So this is the DPM I'm talking about. By explanation, it was 500 gauge polyethylene sheeting that is being laid over the maram blinding. So to enter this one in the squaring column, you simply multiply the length, that is 12.00 meters by 8.00 meters, and that one is giving you an error of 96.00 square meter. So it is that figure that you enter in the squaring column. So you proceed with the same figure to the Bills of Quantities. So by demonstration, this is the formwork I'm talking about. It is done at the edges of this foundation walling to contain the in situ concrete so that they don't spill over, and it is 100 millimeters high. So if I have to enter this one into the squaring column, I simply enter the perimeter. Now let me give you the overview after that close range. So you can see here, we have that formwork that is being done around all the foundation walling. So if I have to get that, I think that these two lengths plus these two widths giving me a total of 40 meters, 0.00. So it is that length of these planks of a formwork that I carry on to the Bills of Quantities. To the 16th item, that is the reinforcement, this one that is being done to this slab work. Explanation will be BRC mesh reference number A198 mass 3.0 kilogram per square meter. So if I have to get the total mass of this mesh, first of all I square the area. So if I square the area, I'm getting 96.00 meters square. Remember, these units are in meters. So for me to get the total mass of this mesh, I multiply this by this, for which if I do, I'm getting 289.92, approximately 290 kilogram. So if I'm now proceeding to prepare Bills of Quantities, this is the mass of this mesh that I'm going to build now. So watch the following video clip explaining this. So by demonstration, this is the BRC mesh, and in a square meter like this one has a mass of 3.02 kilogram. So if I want to get the mass of the whole project, I multiply the area now and get the total area times the mass that was there in a meter square. So as per my case, it is 12.00 times 8.00, giving me 96.00 square meter. So if I multiply that one by a mass of a square meter here, that is 3.02, I'm getting 290 kilogram. So that is the total mass that I'm going to use of BRC mesh in this particular project. So it is that mass that I'm going to build in my Bills of Quantities. Number 17th item will be slab work, and the explanation will be in situ vibrated reinforced concrete, and this is the class, this is the ratio, and it is 100 millimeters thick bed. So if I have to square this one, I simply multiply the length and width, or which if I do, I'm getting 96.00. So if I'm interested further to know the volume of that in situ, I turn this one into meters, or which if I do, I'm going to get 0.1, and I multiply that 0.1 meter by this one now, I'm getting 9.6 cubic meter. So this is the volume of the in situ concrete that I'm going to use when I'm now preparing my Bills of Quantities. So watch the following video, a clip explaining this one. By demonstration, this is the slab work I'm talking about. It has a length of 12.00 meters from this corner up to this corner, by 8.00 from this corner up to this corner. So if I square this one, I get 96.00 square meter. But now if I'm interested further to know the volume of this in situ concrete, I multiply that area by this thickness. Let me give you a close range. I multiply that area by this thickness. Now from this upper edge to this lower edge, this thickness is 100 millimeters. So if I turn this one into meters, it will be 0.1 meter. So if I multiply this one by the area of 96 square meter, I'm going to get 9.6 cubic meter of the in situ concrete. And finally, our last item to be squared is the DPC, and the explanation will be with 200 millimeters across the wall, meaning the DPC must have a width of 200 millimeters as of the wall, and the mini girth as before, meaning it will now again take the mini girth of the wall. So because you have a mini girth of the wall, it has to be 39.20, and it is linear measurement. When we are squaring in this column, we simply carry the same figures up to this column now, or which if you do that, we have 39.20. So this is the same length that the DPC is going to take. So watch the following video clip explaining the DPC concept. And remember, we are in page 8 of 8, meaning we are marking the end of our squaring process. And by giving me close range, this black strip you are seeing is the DPC I'm talking about, the damp-proof course, that is being laid over this slab work. It is being laid before the superstructure work commences from this. But now the 200 I'm talking about is across this DPC, and that 200 is the same width of this foundation walling you are seeing here. So the mini girth is starting from this corner, and remember it is the center line, moving to this corner, to this corner, to this corner, and back to this corner. So it is the 39.20 that we entered in the squaring column. So that will mark the end of part 2, that is the squaring process of substructure works. Coming up is part 3, where I'm going to run through the dimensions, part 4, where I'm going to do the abstracting, and part 5, where I'm going to do the billing or preparation of Bills of Quantities. Now I saw it wise to share my contacts here. You can phone me for private conversation. I'm a activator license. I can now share more information with you. You can even send your question and I do it and then send to you back through PDF or video clip. I'm even available to come to your institutions to assist your trainees. After all these are fellow citizens whom we need to be prepared for the field work now. So the channel majorly I'm also stressing is to give trainees practical perspective of approaching this unit rather than cramming perspective. So up to now, I will just say thank you for watching and remember to subscribe and share and comment please.